Thank you very much, Lisa. Hello, everyone. As Lisa introduced me, my name is Elliot Muller. I'm an analyst at CIRAIG, and I've been working on Impact Focus the past few years, and I will be presenting this webinar today. So the different sections of this presentation are going to be first to introduce what is Impact Plus globally, then having a bit more details about its strengths, specificities, and novelties. Then we have a quick overview on the different indicators that are included in Impact Plus and the different possibilities for interpreting the LCA results using Impact Plus. And finally, a very small part about how to use Impact Plus in your daily life. And then after those 40-minute-ish presentation, we'll have a 20-minute section for discussion. So first, what is Impact Plus? So Impact Plus is a globally regionalized method for life cycle impact assessment, typically called NCIA. And why has it been created? So at the very beginning, it was a conjoint effort of teams from CIRAIG here, the DTU, and the University of Michigan to update the existing methods that were Impact 2002 plus, EDIP and Lucas, and update them in global methods that was consistent and harmonized. And also the big idea at the time was to develop a method that provided indicators that were regionalized, consistent, and at the global scale. So here is the current team. So the board is composed of professors, mainly from CIRAIG, DTU, and IRTA now, and also 4 people are part of the operational team. We are 4 analysts at CIRAIG. And here today with me for this presentation are Lisa Duval, that you already heard, Maxime Agez, who is also an analyst at CIRAIG, and the Professor Cecile Bulle, who will be there to answer all of our questions. So this is the methodological framework of Impact Plus, and I will take that occasion to show you the main things that really present what is Impact Plus, what is the core of Impact Plus. So first, a very important aspect is that Impact Plus is based on two levels of interpretation. So the midpoint, the indicators, also called problem, and the damage level. Then the damage levels can be aggregated in what we call damages on areas of protection, namely human health and ecosystem quality. A third area of protection was theoretically developed, called the resources and ecosystem services. It has been theorized, but it has not been operationalized yet. Another level of interpretation is called the damages on the areas of concern. It has also been theorized and partially operationalized in a specific version of Impact Plus that I will be presenting to you a bit later. And then Impact Plus offers quite a huge coverage of elementary flows, so more than 3,400 elementary flows covered. That's without taking into account the different emission compartments and specialization and other contextualization that can hugely improve the number of elementary flows covered. So that's basically the substances that are covered by any of those indicators. Also, Impact Plus provides 72 impact indicators. That's 24 indicators at the midpoint level, 46 at the damage level, and the 2 area of protection level. And that's globally covering around 15 environmental issues, such as climate change, eutrophication, ecotoxicity, or water use, for instance. And finally, so those 2 last things are also very important in the Impact Plus framework. So most of the indicators are regionalized, and I'll be talking a bit more about that in the next slides. And also for the indicator for which it makes sense, they are temporarily resolved and again, I will be talking a bit more about that a bit later. So now, let's take a deep dive in the different strengths, specificities, and novelties of Impact World Plus. So those are the main features of Impact World Plus that we deem important and that we want to present to you today. So first, the first four that I already talked a little bit earlier, so are going to be covering the comprehensive impact coverage of Impact World Plus, the fact that it includes the latest LCIA developments, that it is based on a process of continuous update, and that it has been developed in mind with consistency and harmonization in mind. So, as I said a bit earlier, Impact World Plus offers one of the most comprehensive coverage of environmental issues among the different impact assessment methods that are currently used and available. So that's 15 environmental issues covered and representing 72 impact indicators. The idea is to avoid impact transfer, or to at least allow the user to calculate the potential impact transfer from one impact category to another while conducting an LCA. The second point is that Impact World Plus integrates the latest developments in the LCIA. So that means that it reflects most of the consensus reached in the climate initiative. It also includes some of the most recent results available. The process we have currently to update Impact World Plus is a continuous, like a process of continuous update. That means that we are using the most up-to-date impact assessment methods for most of the indicators. So that means, for example, the IPCC aware or the latest models for particulate matter formation indicators. We also integrate newly characterized environmental issues. Namely, the two last that were integrated are the fisheries impacts and the plastics physical effects on biota. And also, this process allows us to correct potential issues that would be detected by the community. Finally, a big point that was very important during the development of Impact World Plus, and that is still now in the update process, is the idea of consistency and harmonization across all the impact categories. So that means that the assumptions we are using and that are used in the LCIA model that we select, and during the implementation of the LCIA models, need to be coherent all among the different indicators. And also, that is a very important point, we are very careful of the meaning of the units we're using. Namely, one of the main example is the PDF meter square year that can be quite tricky sometimes to understand properly. Then two other main features of the Impact World Plus framework are the idea of a midpoint and damage framework and the concept of the areas of protection. So first, quick overview of what we mean and what is meant in the midpoint damage level framework. So Impact World Plus provides indicators at the midpoint level. So for example, for climate change, for ecotoxicity, for eutrophication, for land use. And the definition of a midpoint indicator, it's an indicator that can take place anywhere along the environmental mechanism, as long as it is before the damage. Then Impact World Plus also provides indicators at the damage level. So those are indicators of the effects of the substance on the environmental issue that we are looking at. So that are indicators that characterize this effect, well, at the damage level when the effect takes place. In Impact World Plus, those characterizing factors that are developed at the damage level can either be based upon the midpoint level indicators or directly on a direct scientific cause-effect chain from the elementary field. Then a specificity of Impact World Plus is the area of protection, interpretation level, which is really the aggregation of the different damage level indicator. And that is possible because all those indicators at the damage level have the very same unit, namely DALI for the human health indicators, and the PDF meter square for the ecosystem quality indicator. Yes, so the idea of an area of protection is to represent important values for society that we want to protect ultimately. And so the aggregation at this endpoint or damage level at the area of protection level is based on science, because it's based on simply aggregating indicators that have the same, that use the same unit, and having calculated using science specific chain model, rather than weighting that is typically based on subjective judgment. And that's one of the main difference, for example, between impact calculus and the EF method in Europe. So why use a damage level interpretation in impact calculus? So the idea of, well, the interest of a midpoint level indicators is that it is quite robust, because it's closest to what's happening regarding the substance, but it covers a lot of different topics. So as you can see here, that is case study that we used for most of the examples in this presentation. It's comparing two kind of salad, a potato and tuna salad, and a potato and chicken salad. So here we can see, using impact calculus at the midpoint level, that for a lot of indicators, the results are quite different and don't go in the same direction. So for example, for climate change, for the acidification, freshwater acidification, we see that the potato tuna salad is better, like it has a better environmental impact compared to the potato and chicken salad. But on the other hand, for water scarcity, for land transformation, for example, we can see that the other salad is better. So it can be quite hard to take a decision, to make a conclusion only based on midpoint level indicators. So that's one of the reasons to use the damage level, and more specifically indicators regarding the area of protections, is to have lesser indicators, so it makes it easier to take a decision. It makes it easier for decision making. That's a really big idea, and something that impact calculus takes a lot of pride in, and is very important for us, is that we don't make the user blind of the different indicators that contribute to those area of protection indicators. So whenever you are using the expert version of impact calculus, you will be able to calculate, well, to know what of the damage level indicator contributes the most to the different area of protection. And also, as they're calculated using the same unit, you will be able to compare one another. Yes. So here, for example, we can see that for the ecosystem quality area of protection, the land transformation and land occupation indicators take quite a huge part of the impact, and that is especially true for the potato chicken salad. It's also important for the potato tuna salad, but it's less contributing. Whether, of course, the fisheries impact is quite contributing for the potato and tuna salad, but not at all for the potato and chicken salad. And on the contrary, for the climate change, it's almost the same contribution for both indicators. So that allows us to say, yes, the results for the ecosystem quality indicators are quite similar for both systems, but it's not for the same reason. And we can also, of course, do the same for the human health indicator, and we can see here that it's mainly based on climate change. Then another important feature of the impact calculus framework is the concept of area of concerns. So in the methodological framework, in the theoretical framework, the concept of area of concerns was to develop indicators based on measures of interest for the decision maker, namely the carbon footprint and the water footprint. So for this use, we use the definition of the water footprint that is including all the indicators that impact the water compartment or that impact, for example, human health through the water compartment. So that's why it's quite a lot of damage level indicator. So that was the theoretical framework and the way it was developed. It has been recently operationalized in what we call the footprint version of Impact Office that I will be presenting a bit later. But this time it has been a bit simplified using the water scarcity footprint instead of the more complex and complete water footprint indicator. But once again, I will be talking a bit more about that later. Another very important feature of Impact Office is the time differentiation that is used. So, as you might know, different indicators have effects at different period in time. So some indicator represents effects occurring at the short-term level. So for instance, the GWP 100 only focuses on the short-term effects of climate change. So that's everything that is happening before 100 years. And another example, the ecotoxicity of metals typically manifests over an extended period of time. So most of the impact will take place after a 100-year period. So how did we operationalize that in Impact Office? So for the main categories, the main impacts that have impacts at the shorter term level and at the longer term level, namely climate change, marine acidification, human toxicity, and ecotoxicity. We developed different indicators according to if they represented the impact at the shorter term or the longer term. So what you can see here is the first instance, the first example is that if the emission takes place at the shorter term, so in a simplified view, it takes place at the year 0. So we can see that part of the impact is going to happen before the 100-year period, and part of the impact is going to take place after a 100-year period. So to represent that, we developed characterization factors representing only the impacts for the shorter term, and other characterization factors representing only the impact at the longer term. That is for the damage level indicators. So once again, the longer term indicators only represent impact happening after 100 years, nothing before 100 years. So that means that both those indicators, both those results at the damage level are summable. Another case would be if the emission only takes place in the longer term, so at 100 years, for instance. So then all the impact will happen after a 100-year period. So in this specific case, for this kind of emissions, the characterization factor representing the impacts at the shorter term would be 0, and all the characterization factor for the longer term will represent all the impact. So how it made it affect interpretation? So we can see once again this example, which is quite specific, but also quite representative of a lot of LCS that can be done. A big part of the impact, and specifically much of all the impact on climate change, is taking place on the long-term period. So we can see that it takes quite a bit of the contribution to the area of predictions. So yes, it can be quite like the most long term it takes place, the most uncertain it is. So yes, it can be quite uncertain, but it also can represent quite a huge part of the contribution. So it's important to take it into account. Finally, the two last main features of Impact Office are regarding regionalization. So we recognize that some indicators and some environmental impacts have different impacts regarding, depending on the region where they take place, and different ways of defining those regions and different ways of differentiating those regions can lead to different impacts. So Impact Plus is based on characterization factor at the native spatial resolution, and those native characterization factor can be different, like the regionalization level of those characterization factor can be different depending on the indicator that we are looking at. So for example, some indicators such as climate change only have global factors because no matter where the emission is going to happen, the impact is going to be at the global level. For other indicators, such as acidification or eutrophication, the impact is really dependent on the place, like the spatially geographic place where it has been emitted. And that's why at the native level, we use grid cells that are quite fine and detailed that allows us to quantify those impacts very specifically depending on the place where the emission has been emitted. For other kind of impacts, such as toxicity or particulate matter formation, for example, the main important question to ask, regionally speaking, is the archetype of the place where the emission is going to take place. Is it going to be in a low populated area or in a high populated area? Is it going to be like in the high atmosphere or closer to the ground? So that is the main thing that are going to be differentiating the impact of the different indicators. But also for those kind of indicators, sometimes it's really the region of the emission that will be important to take into account for the impact of those indicators. That is, for example, the case for the water use that are going to be the characterization factors natively are going to be specific to the watershed where this water was taken from. So those are the native spatial resolution we use when we define when we calculate the calculation factors for impact of this, and then we aggregate those some of those characterization factors in order to operationalize it and to make it easier to use in the typical LCA tools. So to aggregate characterization factors at the continental or country-specific scale. While doing so, while going from the native resolution, which is a grid monitoring that is quite fine, to a country level, continent level, or even global level aggregation, yes, we make it easier to use, easier to operationalize, easier to use as an LCA, but we also increase the uncertainty based on spatial variability. Of course, a characterization factor that is valid for the global scale is going to be far from the same characterization factor that would have been developed for the native resolution, the very fine regionalization data. So Impact Corpus also provides the uncertainty, like the values of the uncertainties on the CF, on the characterization factors, the uncertainty that is due to that spatial aggregation. Now we're going to be talking a bit more, like having a quick overview on the different indicators included in Impact Corpus and the possibilities for interpreting those, like the LCA results using Impact Corpus. So first thing you need to know is that Impact Corpus comes in 3 different, distinct and complementary versions. So all those 3 versions are available to present an LCIA profile and allow for different levels of interpretation. So first, what we call the expert version. So it's aimed at LCA experts who seek damage impacts. So it includes all the indicators at the damage level and only indicators at the damage level. So the idea is to characterize the damage impact and the contribution to the areas of protection, that are human health and ecosystem quality. So this possibility to aggregate the damage indicators to only 2 areas of protection facilitate the interpretation while keeping detailed and transparent results but they are also a bit more uncertain than at the midpoint level. That is why, of course, we also provide the midpoint version that is aimed at experts who want to stop at the midpoint of the cause-effect chain for various reasons. So those midpoint indicators provide more precise, but also less easy to interpret results. And finally, since the version 2.0.1 of Impact Plus, we also provide a third variation of this method, which we call the footprint version. So the footprint version aims at practitioners who need a more simplified framework that is limited to indicators of general interest in decision making. So once again, I'll be talking a bit more about it in the later slides. So the idea is to facilitate interpretation, but people using it need also to be aware that it is a big simplification of the overall framework. Once again, the idea is to simplify interpretation and like avoid as much as possible mistakes in the interpretation for practitioners that are maybe a bit less expert in LCIA. So we're back to the methodological framework of the midpoint and expert version of Impact Plus. So to build the footprint version, we decided first that the main indicators that are used for decision making are typically the carbon footprint. So we provided an indicator for carbon footprint that is based on the GWP 100 from the IPCC that we call in our framework the indicator on climate change at the shorter term. We also provide an indicator for water footprint that is actually the water scarcity footprint that is based on the indicator that is named water scarcity in Plus. And we also provide a third midpoint level indicator that is the indicator on fossil and nuclear energy use that we call the energetic resource depletion in the footprint framework. We decided to not include the mineral resources use in the footprint version because it's the indicator that is used in Impact Plus can be quite difficult to interpret for non-experts. So that's the reason why it's not included in the footprint version, but of course it's still included in the midpoint version and allows for everyone to use it. Then we also wanted to keep in the footprint version an aggregation of all the other damage level indicators that we aggregated and into two indicators that are based on the previous area of protection indicators that are called the residual human health indicator and the residual ecosystem quality indicator that take into account all of the indicators that are not climate change or water use. And the last thing that you need to know when using this version of the method is that we also decided to exclude all the long-term indicators because as I explained earlier, they can be quite uncertain. And once again, the idea of this method is to really have allow for a simplified interpretation, analysis, and interpretation of the results. So that is the framework, the final framework for the footprint version. So with only 5 indicators provided to the users. So namely the carbon footprint indicator, the water scarcity footprint indicator, the energetic resource depletion indicator, and the residual human health and residual ecosystem quality indicators. So that leads us to those kind of results when using the footprint version. That's really those kind of results, because with the footprint version, you will not be able to analyze the contribution of the damage level indicators to the remaining area of protection indicators. So what does it mean? So for instance, for the human health residual impact indicator, compared to the expert version of the method, first of all, we will delete all the long-term emissions. So as we saw earlier, that can be quite a lot, quite a huge contribution to the impact. So that's the first thing that is done. Then to avoid double counting, we also delete the, sorry, that was a bit quick. We also delete the carbon footprint contribution to those indicators, and then also the water availability contribution to not double count it with the water scarcity footprint. So that leads what is called the human health residual indicator in this version of the method. So people using it need to be very careful in their interpretation and know that it is very, like, what is called in the footprint version the residual human health is very different to what is called the human health area of protection in the expert version, because it only includes the indicators that are not included in the other indicators provided in this version of the method. And that is quite the same for the residual ecosystem quality indicator. So first of all, we delete the long-term emissions, the carbon footprint, the emissions, the impact linked to climate change, as well as water availability, and that leaves us with what is called the residual ecosystem quality indicator. So to summarize, the key advantages of the expert version. First is that it allows the user to keep track of the potential long-term impact. That, yes, can be quite uncertain, but also have a very significant fraction, like contribute very significantly to the damage on the area of protection. So it can be quite important to take them into account when taking a decision. Also, it allows the user to put in perspective the contribution of all the damage level indicators to the area of protection, but also more specifically to the climate change and the water use to the damages on human health and ecosystem quality, and also to compare those different indicators one another, because once again they're using the same unit at the damage level. So that is very important to better deal with trade-offs, of course, and we also consider that it is better to use this way of aggregating damages, because it's based on modeling a cause-effect chain instead of quite subjective value choice. So that allows experts to have a better interpretation possibilities for their LCA results. What are the key advantages for the footprint version now? So first of all, they allow practitioners to obtain easily a carbon footprint, a water scarcity footprint, and a water scarcity footprint. Yes. Also, it also provides them the information about the residual damages on human health and ecosystem quality, and those damages are given in a consistent way, but at the same time while avoiding any double counting that can be easier for decision making. Of course, it also allows to have a complementary indicator, that is the energy resources depletion indicator. So all of that makes it easier to interpret, to analyze, and to interpret for lesser experts. So this table provides a summary of what I just said. We are currently working on developing a decision tree in order to help users of feedback corpus to decide which version of the method is the most useful for their context. But this table can really englobes most of these informations and can be used as a decision-making tool for the version to use. And finally, quite quickly, I'm going to present you the different practical versions, the different operational versions that are available for Impact World Plus that you can use in your daily work. So first, as I said earlier, we are based on a lot of native data that we call our source and that are included in a database in the SQL format that is open access. This allows us to calculate the different versions of the method at the midpoint level, at the expert or damage level, and at the footprint level since the version 2.0.1. Historically, the midpoint and expert versions were provided using the carbon neutrality approach for biogenic carbon. But since the version 2.1, we also developed versions that are using the -1 and +1 approach that we call in those frameworks the climate change including CO2 uptake indicators. Once again, it's to allow for different levels of interpretation for the LCA practitioners. For the footprint version, we decided to only use the carbon neutrality approach, once again, to simplify the interpretation. Once all of that is done, first of all, the different things that are available is what we call a developer version, which is quite often an intermediate version that allows for people, for example, using Python or not using traditional LCA tools to still have access to the LCA, to the characterization factors and to use them the way they want. And yes, and then we also provide ourselves, we develop ourselves files, so versions of these different versions of the method that can be directly integrated and used in three of the main LCA tools currently available, namely CIRAIG, OpenLCA, and Brightway. We also provide Excel files that can be used directly with Equinvent or Excel-based database, for example. And for all those files, we either update them at each version to the most up-to-date Equinvent version, or for instance with Brightway or for version directly usable with Equinvent, we provide versions for different versions of the Equinvent database. Finally, where to find everything impact purpose related. So all the documentation is available through either the published article directly on the website or on GitHub or Zenodo. You have the links in this presentation that you will be able to access later. For the code, it's open access and it's available on GitHub. The native database is available on Zenodo or on demand. And finally, the operationalized files. So the version, our own version that we developed ourselves, are available, all of them on Zenodo, that you can access and you can find through our website. So that is the case for the different software and also for different databases. Also, versions of Impact Corpus are also available directly provided, for example, in the Equinvent package or directly on EcoQuery. So that is the version 2.1 that is available, but only the footprint version, and it's not regionalized, as Equinvent doesn't provide regionalized elementary flows directly. It's also available on the OpenLCA package and on its the annexes, as well as on the CIRAIG package that is for the midpoint and expert level. And also, for instance, it's directly included in the OpenIO Canada database, and that's for the most recent version. For all the others, so namely CIRAIG, OpenLCA, and Equinvent, yes, they are provided through these providers, but we highly recommend, if you have the option, to use our version that we provide on our Zenodo, because we are more certain that they are up to date. They provide regionalized factors, and as I said earlier, you will be able to access different versions of this method, so namely midpoint, expert, and footprint version, as well as the two different types of way to take into account organic, biogenic carbon. So yes, you basically have more options with that. And with that, I will thank you for your attention and open the floor for the question period.